All right, when two angles in a triangle are congruent, to two angles in another triangle, the third angles of each of those triangles will also be congruent. Therefore, the triangles will be similar. Triangles are the only shape where if you can tell me that all the angles are congruent, all the sides will be proportional. Remember our definition of similar figures back from a chapter ago. Similar figures have angles, corresponding angles that are congruent, and then corresponding sides that are proportional. So one of the test questions that we went over yesterday was, I think it was gave us two rectangles and asked us if they were similar, and they weren't. They weren't similar because their sides weren't proportional. But in triangles, it's the only shape where you don't actually have to check the sides. If you can prove to me the angles are all congruent, the corresponding angles are all congruent, the sides will automatically be proportional. It's the only shape that works like that. Okay. Yes.
Why is that?
I think because of the fact that because it's a triangle, the opposite side of that angle. So like when I widen that shape, it's going to have a similar. When I widen the angle out, right? It tells me what the length is. I don't know. Again, because it only has three angles, I've got one angle here, and if I draw a line right there, you've got the other two angles. Like I can't draw a shape. I can't do this with a pentagon. I can't just say, well, this is one angle like this. Ooh, that's a bad idea. Let's use something that I could fall and I'd be okay with it. Okay. There's a triangle, right? I widen it out. Okay, well, let's just go with this. Here's a triangle. It's not perfect. Okay. Here's a triangle. If I take this triangle and if I try to make a similar triangle from it, all the angles are going to be the same. All the sides on that are going to be proportional because the triangle is only one triangle with the angles. Remember the theorems we looked at with unique triangles? Okay, remember the SSS one? There wasn't one with AAA. If you have angle, 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 if you can prove that the angles are the same, then they will be similar, not unique, but they'll be similar triangles. Whereas with a rectangle, I can have 90-degree angles and draw a completely different looking rectangle than someone else, right? So just because our angles are 90 degrees doesn't mean our rectangles are the same. But in triangles, because I guess there's only three, that would be true. I'm not 100% sure. I don't know if you can tell from my explanation that I'm 100% sure on why that is, other than someone older than me proved it a long time ago. So now, for example A, do you see two corresponding angles that are congruent? Yeah, we see the 50-degree angle here matches with the 50-degree angle there. So those are going to be corresponding. And then we see the 75-degree angle here matches with the 75-degree angle there. And so what that means is angle X and Y are actually the same angle. And you can prove that using the triangle sum theorem. If you take 180 and subtract 50 and then subtract 75, you're getting the same answer here as you would if you did it for this triangle. So if you can prove that two angles are going to be the same, it's guaranteed the third angles are also going to be the same. So these triangles would be similar. All right. So in this next triangle, do you see a 63-degree angle in both? Okay. Do you see a 54-degree angle in both? No. But instead of saying these aren't similar, maybe I should dig a little deeper. In this triangle, what's 63 plus 63? Person? 126. What's 180 minus 126? Is he? So it's not as easy as just looking at it. Sometimes I do need to investigate, but here's what I do know. Since this angle is 54 and this angle is 54, I should have used a different color. it's guaranteed that angle X is going to be 63 degrees because its angle has to match up with, because I just proved that two corresponding angles are congruent. I can prove that these two angles will also be the same. So that one's going to be 63, and we know that obviously Y was 54. So they are also similar. So if you don't automatically see two sets of equal angles, you need to go ahead and double check and use the 180 minus the two that you have just to see if this. So for example, in this one here, let's double check to make sure before we just say no. We have two 90-degree angles. So there's one. I need angle X to be 38 degrees because I know 42 is not the same as 38. So I need angle X to be 38 degrees in order for this to work. So I do some quick calculation. I take 180 minus 90 minus 42, which is the same as 132. What does that leave me with? Christian, what's that leave me with? 48. Okay, I needed it to be 38. So so if this is 48, I don't even have to check to see what angle Y is. It's going to be different. These are not going to be similar. I've only got one set of angles that match. And again, I don't need to check out what Y is because Y, even if it was 42 degrees, the 48 and 38 still won't match. So, no, actually, no, that's not true. It wouldn't be 42 degrees. Otherwise, it would have matched. They wouldn't be 42 degrees. If you do the math on that, if you do 180 minus 90, and then 38, which is 128, that's going to give you 52. So both of them are 10 degrees larger than the angle you wanted it to be. All right. Next example says use the fact that two rays from the sun. Oh, we talked about this example yesterday. Use the fact that two rays from the sun are parallel to explain why triangle ABC and why triangle DEF are similar. Then find the height of the flagpole. Well, if the sun's rays are parallel at the same time of day, and you can think of the ground as a transversal, this takes you back to the quiz you took on Wednesday, then this angle here and this angle there, you can't see that very well. This angle here and this angle there are what type of angles? We have a name for those angles. Someone other than Xander should remember this. You took a quiz on it. Someone other than Lizzie or Owen. Martin knows. Martin, what kind of angles are they? They're corresponding angles. Yeah, so we know corresponding angles are congruent. So if we know that those two angles that I've highlighted are congruent, and if we know that this right angle on the bottom here is going to match with that angle right there, then we've just proven that two angles are congruent. Therefore, the third angle in each of them will be congruent. Okay, so we know because of corresponding angles, we know that this angle C is going to be the same as this angle up here, which I can't even tell what that is. Angle F, I think. Okay. So they are similar triangles. And if they are similar triangles, we know their sides are proportional. So to find the height of the flagpole, we can set up a proportion. Does anyone want to tell me what they think their proportion would set up as? Jace, thanks for volunteering.
1/12.
1/12. Where are you getting the 1/12 from?
Well, 36 divided by 3. Well, wait, no. Wait.
Okay, back it up one step. What's the height of the child?
5.
And what's the shadow on that same child?
3.
Okay, so I could go 5 to 3, and with that ratio, can you tell me what the other ratio would be? So I did height of the child, over the shadow of the child. So height of the flagpole, reverse it. You're too far ahead. Height of the flagpole, we don't know it. So what did they call it? X, okay. And then the shadow on the flagpole, 36. Okay, yeah, you just way too far ahead. Not the only way you could set this proportion. You could also, instead of doing child's height, child's shadow, flagpole height, flagpole shadow, you could also do child's height, flagpole's height. And then you could do child's shadow, flagpole's shadow. So there's more than one way you can set the proportion. Now, Jason, I'm going to have you work through it. Obviously, we get the 3 times X there. What about 5 times 36? 180, and divide by 3, and we get, I wondered, yeah, I was gonna say you had it. Yeah, 60, and then we're gonna label it, story problem, we're gonna label that 60 feet. So that flagpole is 60 feet. Okay, and as I mentioned yesterday, this is called using indirect measurement. Indirect measurement uses similar figures to find a missing measure when it's difficult to find it directly. It would be difficult to climb the flagpole and then dangle down a tape measure for that. Well, now you could probably ask the manufacturer who made the flagpole just how tall it is, but you wouldn't be able to do that with a tree, for example, whereas you could measure the height of a tree by doing something similar. Now, that would get a little bit messy because then you've got the branches of the tree that are causing different, the shadow on the tree would look a little bit different than your shadow. But for the most part, you'd be able to get a pretty good estimate on that. All right, next one. You plan to cross a river and you want to know how far it is to the other side. You take measurements on your side of the river. This one I almost feel like it would be easier just to throw a tape measure over, but I don't know how long the river is. Or how wide it is. You take measurements on your side of the river and you make the drawing shown. Explain why triangle ABC and triangle DEC are similar. And then what is that distance X across the river? So proportions will not work unless you have similar triangles. Can someone explain to me how they know these two triangles, triangle ABC, which is this one here, and then triangle DEC, why are they similar? Take a crack at it, Lizzie. They both have right angles. Okay, that's true. So we've got one matching set of angles. How many matching sets do I have to have? 2, because if I have 2, I'm guaranteed to have 3, right? Okay, where's my other matching set of angles? Owen? Say it again. What about C? Yes, there it is. I thought I heard you say that. They are vertical. So because we know vertical angles are congruent, we can prove that angle C on this triangle and angle C on the other triangle are congruent. And if we can prove that there are 2 matching angles, we know the third set of angles will also match. And therefore we do have similar triangles. So now that we have similar triangles, we are able to use a proportion because their sides are proportional. What would my proportion look like? What would you write, Jacoby? Okay, so 50 over 40. Jacoby used the base, I guess you would say, of the left triangle, top triangle, with the base of the bottom triangle. And then now you're going to do their 2 heights. And go ahead and tell me what the other ratio was. 60 over X. Yeah. So Jacoby did 50. There's some serious lag today. There we go. He did 50 over 40. And now he's going to do the other side of that right angle. Goes back to the top one, 60 over X. And Jacoby, when you cross multiply, you get 50X or equals, what's 40 times 60? And divide by 50? 48 what? 48 feet. There we go. Pretty simple lesson tonight, right? The only thing that's new is the fact that we just said that it only takes 2 matching set of angles for the triangles to be similar because you're guaranteed to have a third matching set if you can prove the first two are matching. So that's really the only thing we're checking for here. All right, I got one homework problem and we'll be done for today. Number 14 says the lengths of a triangle are increased by 50% to make a similar triangle. Does the area increase by 50% as well? If I increase the side lengths by 50%, so they're 150% of what they were, is that going to make the area 150% of what it was? Can you prove that the answer is yes or no? Carson? Ah, you're exactly right. So do you remember last chapter, we talked about side length ratios, perimeter ratios, area ratios, volume ratios, right? So the side length and so if they increase the side lengths by 50%, it will increase the perimeter by 50% because that ratio was the same. But when you talk about the area, that has a exponential effect, right? That's going to square. And so let's figure out what it would actually be. The area of the similar triangle, it says blank increased by 50%. That would be, I'm going to guess, does not. I mean, I know it's not, but I'm going to guess the words you're looking for there does not increase by 50%. The length of each side of the triangle increases by there's the percent increases by 50. The length of each side of the triangle increases by 50%. So, increases by, we're going to say 150. Wait, 50, is it 50% or 150%? 50%. Okay, I'm thinking, I'm trying to think it. So it's 150% of what it was. And that's where they're getting this scale factor of 3/2. Because 3/2 is the same as 1.5 and 1.5 is the same as 150%. So if you take the side lengths, if you're wanting to do a 50% increase, you can't times it by 0.5 because what's timesing a side length by 0.5 going to do? Is that going to increase it? It's going to take what? Half of it. Yeah. So I have to times it by 1.5, which is why the scale factor of 3/2 is here. Because remember we talked about last time, if your scale factor ratio is smaller than 1, it shrinks it. Reduces it. And if your scale factor is larger than 1, it's going to enlarge it. And so we want to enlarge this by 3/2. So if you times the side lengths by 3/2, then you have to times the area. The area ratio would be 9/4 because we have to square that ratio. Okay, and what is 9/4 as a percent? Sky? 225%. That's right. So if you take 150% times 150%, or 1.5 times 1.5, you will get 2.25. Which is 225%, which is where she's getting that from. Okay, of the original area, which is an increase. It's an increase of what then? Remember, we're starting at 100% already. So what's an increase of? Carson? Say it again. Not 3.5. Oh, yes, you're right. You're right. 325. Yep. Percent. That's right. Yeah, because you're starting at 100. So you add the 225 onto that. Yes, Sky. Is it 125? I was gonna say there's a reason I was doing this one with you, and I think I'm just confused by the language of it. Increase of, again, starting at 100. So if you subtract away 100 from that, it's 125% of what it was before. Okay. Thank you. I'm glad you guys have the check or the drop down arrow button. Okay. I just thought it was interesting because we talked about this last chapter and we know it's not going to be the same ratio, but it's going to be the square of that ratio. All right, that's perfect timing. Look at that. So when you guys come in on Monday, 3.3 is going to be due. It sounds like you guys are doing all right on 3.3. Okay, you haven't started it yet, have you? You haven't started it yet? 3.4 is gonna be due Tuesday.